right, pre-algebra, we are going to continue on with CO12. First, going over the ones that I got to do for homework, and then doing some more work with roots. This is the last objective of the unit, so expect a test coming up post-haste on Thursday. Tomorrow will be a test for funsies, and then Thursday is a test for realsies. So you did need to show your work on this, which all of you who did the work did. Thank you for that. But basically, you're using that chart on CO11 to help you identify where on the number line, right, these roots fall. So root 94, you should have, and we're not going to show the work for all of them here, but just the first one. Root 94, you should have root 81 and root 100, because 94 is between 81 and 100. Now, what's special about 81 and 100? Yes, Shane?
Between 9 and 10.
Right, they are perfect squares, okay? Root 81 is equal to 9, root 100 is equal to 10. So if 94 is between those two perfect squares, that means its value is between 9 and 10, right? And so we've got 94. We now see how close it is to both sides. It's closer to 100, therefore it's closer to 10. So I would accept any one of these answers, 9.6, 9.8, 9.7, 9.8, or even 9.9, just because you're showing it's on the correct side of 9.5. It's an estimation.
Now that there's snow out, it's the spirit of Christmas.
It is. It is.
No,
James.
it's not.
Yeah.
It's the spirit of Christmas.
What?
It's not even in
9.5? No, it's not.
Spirit of Christmas?
These four, I mean, you should not be putting 9.9 here, right? It's not right up. This is the spirit of Christmas one, the 9.9. The fact that I'm accepting any of these four, that's the Christmas spirit right there. Root 10, you can have 3.1, 3.2, 3.3, or the spirit of Christmas 3.4. It is just a little bit bigger than the root of 9, which is equal to 3. So 3.1 is the best answer, but I would accept any of those things. Root 212 is between 14 and 15. It is closer to 15 than it is to 14. So any of these answers would be okay. Incorrect. That one there. That's incorrect. Yeah, it's between 196 and 225, which is between 14 and 15. It is closer to 225 than it is to 196. That's why we have these answers here. Root 101, that was on the homework check, so we don't need to talk about that. 10.1 would be your answer there.
Christmas 14.3.
Well, no, that's not it. There we go. That one. That's one.
Do haha.
Next one, root 21 is between 16 and 25. Now, if there was any one to where I would accept a 0.5 in the spirit of Christmas, this one would be it, because it is about halfway, right? It is a little closer to 5 technically, but it is pretty much in the middle of 16 and 25. So in this case, 4.5, 4.6, 4.7, 4.8, 4.9, any of those would be okay. Root 76, I think that was on the homework check as well. You should have somewhere between 8 and 9, closer to 9 than to 8. So we'll go with these four answers here. Root 132, this was on the homework check as well. This is pretty much in the middle of 11 and 12. It is just a little bit closer to 11. So I would accept 11.5 or 11.4, 11.3, 11.2, or even 11.1. And then root 85, that's between 9 and 10, between 81 and 100. It is closer to 9. So 9.1, 9.2, 9.3, 9.4. Not 9.5 because it is not that close to being in the middle. Questions on those four? Okay. So the rest of CO12 is pretty similar stuff. We've got some word problems to work on. But first we're going to start by working backwards. It says we're going to shift our thinking and work backwards. For each decimal below, estimate its value written as a square root. So normally I give you the root and you tell me the approximate decimal. Okay. In this case, I'm giving you the decimal and I want you to give me the approximate root. So who's got a guess for this? Not a guess. Who's got an idea of what the original root that would be approximately 2.7 to the 80?
The square root of 9.
Okay, so the root of 9 is going to be exactly 3, right? we can still use our charts to help us because 3 is the next integer here. 3 is equivalent to the root of 9. What's the next smallest integer? 2, right? 2.7 is between 2 and 3, and 2 is equivalent to the root of 4. So kind of, again, thinking backwards here, we know that 2.7 is between 2 and 3. We're looking for a root that's between root 4 and root 9. Root 5, root 6, root 7, root 8, which one's the best answer? Schlafer? I'd say root 8, okay? We wouldn't want root 5 because root 5 is just a little bit more than 4. That'd be like 2.2, something like that, right? But root of 8 would be the best answer there, okay? So that's what you're doing for this section here. Let's do 7.1 as well. The next smallest integer is 7. What root is equivalent to 7?
49.
Root of 49. The next largest integer is 8, right? 7.1 is between 7 and 8. What root is equivalent to 8?
64.
Root 64. So your answer, your root, that'll be about 7.1, you know has to be between root 49 and root 64. Is root 60 a good answer here? No. Root 60 is too close to 64. That'd be like 7.8. We want 7.1. We want something that's just a little bit bigger than 7. So what would you think, Liv?
50.
Root 50 would be good. I'd accept root 51. Root 52, right? Something that's really, really close to 49.
What about 50?
Because what about what?
53.
Spirit of Christmas. But then again, I am the Tin Man and don't have a heart.
Oh, we don't.
So,
You have a heart in your chest right now.
well, that's
You have
just
a clock.
like a pocket watch, not an actual.
But
Well, I have an
I
actual.
feel like there's a TikTok joke in there somewhere.
Ha.
But I'm not quite sure on it.
That's
Yeah.
Ha ha.
So say for like 2.7, could you put 2.71? That'd still be correct?
As an answer?
Yes.
Well, your answer needs to be a root.
Yeah, I'm saying like for like the other thing.
Oh, to go to 2 decimal places?
Yeah.
Sure. Yeah. If you want to go that route. Sure. Okay. So these other 2 are homework, right? You'll have time to work on it probably, but circle those, right? The 2 that we didn't do, 3.8 and 5.9. And then you've got some word problems here also. It says, your grandparents own a large plot of land in rural Minnesota. An old map they have shows the plot to be a square with an area of 200. If you remember, this is actually how we started CO12, right? I gave you a square, I gave you the area, and I said, what are the side lengths of the square? That's how we introduced taking the square root and estimating square roots to begin with. Because remember, a square, all 4 sides are the same. So if the area is 200, we talked about the reason why it's called a square root. Taking the square root of the area of a square gives you the side length of the square, right? And when we first introduced it, we did the root of 25, which was easy because 25 is the perfect square. Then we went to 34, we were stumped, and then we launched into how to estimate these. So you're essentially doing the exact same thing that we have been doing, right? Recognizing that with the area of a square, that's your key. Area of a square, to find the lengths, you're approximating that root. Now remember, on the test, you are not able to use a calculator. So instead, use the charts to help you with this answer now. A square bulletin board has an area, square, area of 66. What is the length of one of its sides? Am I asking you to do anything different or new here? No, same thing. You've got a square, you know its area, you're looking for the length of one of its sides. You're estimating that square root. Okay? A square garden has an area of 42 feet squared. Again, square, area. How many feet of fence do you need to enclose the garden? This time I am asking you to do something a little bit different. What are you looking for here? How many feet of fence do you need to enclose the garden? What am I asking for? Who said perimeter? Matilda? Excellent. Okay. Feet of fence to enclose. I'm asking for perimeter. So do you still need to find a side length of the garden, a side length of the square? Yes. But whereas that's your final answer for these two, right? You've got to go one step further for that one. Once you get the side length of the square, what is the perimeter of the square? Right? And I believe that is it. Oh no, time for review. What is the order of operations? And explain how a radical is the opposite of squaring. We kind of introduced that in PERMDAS. Exponents and radicals are opposites. We talked about it yesterday as well. How is that relationship happening? Okay. You have 12 minutes to work on this homework now. We will check it in tomorrow. Great day for a number game tomorrow. You'll have all the saints backing you.
We didn't get it?
Today, we did not get it today. Several people didn't do the second page, the top four on the second page. But tomorrow, I believe in you all, because you got 12 minutes to work on it. Yes.
My pencil box. No, I didn't.
Aim, can you return the pencil box, please?
It's also home.
I will open back up the pre-algebra bell or homework check from today now. So if you need to do that, you can do that now. Do yesterday's as well. Please don't forget about them. But there we go. Any more buttons I want to press?
Do the ha-ha one and the bottom purple ones.
Always for you, Harrison. The bottom purple ones. I forget what. Oh, someone needs to give me a compliment.
I like
No,
the
not
costume.
the top
I
purple.
like the tin can suit. I like how.
And now I need someone to complain about something.
Oh,
You're a
high.
What's that? Can't cry or it'll rust. Okay. There we go.